All right, good morning. Welcome to DEV302. Now, I've promised myself that I will not make any Friday morning after Thursday late night party jokes, so please keep me honest. I will avoid it, but really appreciate you guys coming here at 9 o'clock. We are super excited to bring you what we think is a very valuable session, and as we go along, you'll see some really interesting things. My name is Prashant Prahlad. I am a product manager at AWS, part of the management tool services, and my partner in crime is Armando Late. Armando is a global security architect in our professional services team, so you'll not just see the product version of this, but also the real-life version of how customers are using some of the stuff we're going to talk about. So this session is going to be a little bit different. What you're going to expect from it is we have 3 big white papers: automating governance on AWS, AWS Cloud Adoption Framework, and security and governance at scale. In this session, we're going to read through 34 pages of automating governance, 39 pages of the Cloud Adoption Framework, and 14 pages of security and governance at scale. Sound good? As a culture, we don't do enough reading, so I thought this is a good time to actually just read stuff. Friday morning, 9 a.m. All right, I was kidding. Don't leave just yet. So there's a lot of value in those white papers. So I put them up because there's a lot of thought that has gone into each one of those white papers. And what we're going to see today is how you take that thought and implement it in your data centers, in your AWS account, not data centers. And we're going to look at 3 phases of governance. The first phase is control, where you prevent bad actions from occurring in your AWS accounts. The second phase is monitoring, just generating awareness about what's happening in your account, what users are doing. And the third is when something bad happens, how you can force a timely fix on those actions. Now, in the context of these 3 phases, I'm also going to show you examples of new things we launched over the last week. So yesterday, Werner announced the EC2 Systems Manager product, which it helps you manage your EC2 instances with patch management and automation. AWS Config is a service that supports EC2 Systems Manager, and we'll see how that helps you monitor things beyond AWS, software configurations and so on. And on the force fixes side, we also launched last week something called the CloudTrail S3 data events, and we'll see how you can use CloudTrail data events to force timely fixes on your account. And part of these phases is, we didn't really want to make it 3 distinct phases. We want to automate it, and Armando will show us how that's all coming together. And at the end of this session, you get your own take-home toolkit. So this is not a concept, it's not a POC. You'll get a toolkit you can take home and implement, or take to work, rather, and implement. So what's the problem here? You've probably seen this slide a million times. If you've come to reInvent, or if you attended any reInvent session related to security, you'll see that there's a shared responsibility model with AWS. There's a part that AWS is responsible for, which is this security of the cloud, and there's a part that the customer is responsible for, which is security in the cloud. And we provide various sets of tools and services to help you get the customer part of that responsibility. And we talk about DevOps and developers, and who's doing the security bit here? Is it the dev side, or is it the ops side, or is it both? And it's kind of diffused, and that's, I think, the problem, right? We've seen customers run into some very common problems. First one is security is somebody else's responsibility. If you're a developer doing DevOps, security is handled by some centralized team. And then the folks who actually read this stuff and try to do the right thing, they run into things that are written in legalese that's hard to actually take from concept and actually implement on a regular basis because, we don't read. And then in some cases, we've seen customers take their practices that they've implemented in their data centers and then apply the exact same thing in the cloud. And while that's okay to get started, it doesn't actually scale, right? Because there are manual processes, there are configurations you can get away with in the data center that you want to actually fix when you're in the cloud. And the most important thing I've seen so far is there are a lot of smart people who've done a lot of interesting work, and it's not shared, right? You see that people are just relearning the same thing some other person has learned before. So it's really important to tap into your community, right? And reInvent's a great forum for doing that, but your meetups and other places are also great, but we don't see enough of that. And I'll give you 2 examples of real customer cases. Of course, I've taken out the customer names, but these are real things I've heard. One of them is an example of a new team delivering a new product. They get a new AWS account. Because it's the fastest way to get started, everyone has admin privileges. Credentials are hard-coded in code. That has happened. They don't enable CloudTrail because that's for audit people, and we don't really care because we're developers and we want to get stuff done. Ports are open, and there was no concept of gamma or test and prod. The test became prod, right? And the project was launched on time and mission accomplished. And things never change from test. That's production. This has happened. Another example is when customers are experimenting, right? I've seen examples where there's some experiments you want to run, and then you assume that your workloads require high I/O or high CPU, and the CPU instance type you choose is far greater than what you actually need. And you forget to turn these off, like idle instances. And the rationale I've heard is, we're just a tiny drop in that big bucket of AWS charges, so it doesn't really matter, but it does. So these are some common problems I've seen, and I thought I'd use them as examples of why this automated governance system is important. And I mentioned 3 phases: control, monitor, and fix. And we look at what each of these means. Control is basically preventing bad actions from taking place. You have various sets of services that map to these actions. CloudFormation helps you templatize resources so they're provisioned in a consistent and repeatable manner. So you don't have 5 different configurations to take care of. There's one standard one. Service Catalog is an extension of CloudFormation. So you can actually have, you can limit what your users can provision. We'll look at that in detail. Using IAM policies, of course, is the best way to prevent people from doing things that are not authorized. Disabling root credentials, and then checking on GitHub for public access keys. This is an important one. So I think everybody knows what CloudFormation does. Templatized resource provisioning, consistent way of actually provisioning resources in your account. CloudFormation pretty much supports most resource type, if not all of them, that you normally use. It also supports YAML, and there was a presentation earlier about using code pipelines with CloudFormation. So really, infrastructure as code, being able to provision something consistently so you prevent errant configurations. Service Catalog, as I mentioned, has 2 sort of interfaces. The administrator will say, these are approved configurations, approved products you put in your product portfolio, and then the customer can only provision the things that you put in your portfolio, right? And you can add constraints to make sure that people have flexibility but don't move beyond the constraints you provided. So these are ways in which you can prevent bad configurations. Now, IAM is another way. So remember I mentioned people using the wrong instance type? In this case, as an example, you can only provision T2 and M4 type instances. So you don't have the expensive instances being part of the IAM policy. So you prevent people from doing bad things. And of course, access keys. So if you haven't already, you should check out the SAC 317 IAM best practices to live by. And some of the things that are mentioned there, you should implement because these are sort of bread and butter security stuff. Do not generate access keys for your root account. Use IAM roles. And I also mentioned there's something called Git secrets that you can embed, and that's the link for Git secrets that you can embed with your development process that actually checks that you're not checking in access keys into Git, right? Very important. You should never check access keys into Git, but that's why their tools exist to prevent that. Now, if you're thinking, this is really simple, I knew all this before coming in, don't worry, it gets more and more complex as we go through the presentation. There's not much you can show about having no permissions. You get error messages like this that prevent people from doing bad things. In this example, I don't have IAM permissions to even use a service. And the next example, I'm trying to turn CloudTrail off. And I've actually had deny permissions on CloudTrail stop logging. So you can't actually turn a service off, right? So these are preventative actions. So we saw control. Let's look at monitor. Now, there's very little reason to not turn services like CloudTrail and AWS Config on. You get data that you can then use later. If you think you get too much data, or if you're worried about cost, you can always apply lifecycle policies to archive it in Glacier or something like that. So we'll look at each of these in detail. Everyone should know what CloudTrail is at this point. Yes? CloudTrail is a service that logs API calls in your AWS account, fundamental, right? Gives you visibility into what a user is doing in your account. Important things for CloudTrail. First one, if you have a centralized environment where you have a security team and a development team, you can create multiple trails in your account, so each one gets a copy that's unique. And you can also turn on CloudTrail in all regions. You can turn it on globally. So if you have CloudTrail turned on, and if you're not using a region X, just turn it on globally, because if somebody's using something in region X, you'll get logs for it. And most recently, we announced S3 data events. This is the ability to get object-level API activity in CloudTrail. And we also announced event selectors, which is applying the right kind of filters to your trail. So let's say you're a developer and you want to only get mutating actions, not read actions. You can apply that filter to your specific trail. And let's say your security wants all that data. They can get both read and write access into another trail. Now, I'll show you S3 data events with an example. Config rules was also recently launched at reInvent last year. And config rules together help you assess and monitor the situation in your account, whether your configurations are acceptable. And the rules are automatically checking configurations to make sure there are no bad configurations in your account. Now, what you get at the end of it is inventory of all the resources that exist in your account if you turn on config. And then if you turn on config rule, it'll tell you whether those resources are compliant or non-compliant with specific rules that you've defined. So in this example, I have a rule that's checking for restricted SSH, and it's checking whether my security group applies as SSH disabled or enabled, and you see that these are non-compliant. And you have the other pivot on the same data where you're looking at a specific rule and then looking at the resources that comply or don't comply. Now, yesterday, we made a very, very quiet announcement. EC2 Systems Manager was announced in the keynote, but what followed on was AWS Config support for software inventory. So software inventory is applications, Windows patches, AWS components installed inside your AWS instance. EC2 instance is now available in config, so you can actually write rules against them. And we'll look at that in a second here. So in this case, you go to config, there is a new resource type called the SSM, or Simple Systems Manager, Managed Instance Inventory. Now this specific resource type has You will get to the rules in a second, but if you just look at the raw resource, you can click on the time icon here. And it's just like a regular AWS config resource, which captures details about that configuration. You'll notice it's an extension to an instance. So this is data about things that are inside your instance. So it's related to the instance. And when you look at Windows updates, you can look at all the patches that have been installed on this instance. In this example, this is a Windows instance, so you can get the patch level, the version, the date at which it was installed, and you get a full history of all the patches that have been installed. Applications. So you can get, not just the AWS applications, but other applications that you've installed inside your EC2 instance. So if you have a Firefox installation and you're concerned about the most recent security vulnerability that was announced, you can actually detect that a specific version of Firefox was installed in your instance, for example. The next one is AWS components. So these are AWS agents and other things that are installed. It might be worth mentioning at this point that you don't really need a brand new agent to run this, right? This is already part of the EC2 Systems Manager agent that existed already. So we're just collecting this data in AWS Config. Now the value of this is not just in collecting the data for archival and audit purposes, but the ability to write rules against them, right? You're monitoring not just what applications are installed, but whether these versions of applications are useful or not. Now in this case, I'm looking at a rule that's checking for platforms, whether whether a specific version of Windows is installed. That's one rule. The other rule checks for application versions that have been installed, make sure these applications exist. And the third one you're looking at here is blacklisted applications. So make sure this application is not installed, or this version of application is not installed in your instances. Now, these are managed rules that we provide as AWS, but you could pretty much write your own custom rules. Now, in this example, it's just checking that these applications are installed, and you see that 3 of my resources don't have that specific application, AWS CFN config, and one of them does. So it's just an example of the kind of things you can do. Do not stop at these managed rules that we write for you. If you go to GitHub, you'll find that there are a lot of different rules that you can create. And of course, for the systems manager piece, it's relatively new, so we'll start building that portfolio of rules soon. So when it comes to monitoring, we have to talk about CloudWatch. CloudWatch is a broad portfolio of products that you have to enable for monitoring. You have metrics and events and logs that are generated from AWS resources, but CloudWatch also supports the ability to generate metrics and logs from resources such as applications. So these are custom metrics, logs, and events. You can actually trigger automated notifications on CloudWatch. Basically based on metric thresholds that you can define on your own. You can diagnose issues using CloudWatch logs, being able to search logs for specific actions. It's fairly easy. So CloudWatch has metrics, logs, and events, and they're all fairly integrated. And of course, you can also trigger Lambda functions using CloudWatch to actually resolve the issues that you see, perhaps. And these are CloudWatch events rules, and we'll see an example of that. Now, when you have these kind of monitoring tools, an important question that arises is, who's watching the watcher, right? What if somebody turns off CloudTrail? What if somebody turns off AWS Config? Like, how do you prevent a situation like this? Well, you write the next monitor, right? There's several options here. One is you actually lock down any kind of changes to these fundamental services. All of these services have read-only IAM managed policies. So for example, the CloudTrail read-only managed policy exists. Config read-only managed policy exists. So if you only allow users to use this policy, they can view the data but not turn these services off. So you can lock it down. Now, in some cases, people don't like to be locked down, or people don't like locking themselves down. So they actually can also do explicit deny actions in the IAM policy. So things like stop logging in CloudTrail, update trail, these are mutating actions you can take on your resources that matter to you, so you can explicitly deny them, right? And these are examples for some of the services we just talked about. With CloudTrail, start logging, stop logging, update trail, create trail are examples. With PPC flow logs, create flow logs, delete flow logs, and we'll see this in a little bit more detail. And of course, you can also use config rules and Lambda to actually turn the services off. And that's the example I'm going to show you here of how you can monitor the monitor. So in this case, I'm going to turn CloudTrail off. But first, I'm going to try and create a trigger from CloudWatch events. I go to CloudWatch events, and then I have a rule here that I'm going to create and say that anytime somebody does these set of actions on CloudTrail, right, delete trail, start logging, stop logging, I'm going to add a Lambda target, and the Lambda target is a function I just wrote, and I'm going to show you a glimpse of it. All it does is start logging. So anytime anything happens, it just does start logging, right? That's it. It's code that you can find on GitHub. It just calls start logging. And I'm going to just finish up the CloudWatch events function here, which is, make sure CloudTrail is always turned on. And then I go to CloudTrail, and now we've set up the infrastructure to monitor and fix the problem, right? Or monitor the monitor, rather. I have CloudTrail in Ireland. It's turned on. And then if I turn it off, and within about, this takes about maybe a minute, and if you refresh it, it gets turned back on. Now you could, this could drive some people nuts because they're trying to perform an action, but it's kind of going back to what it was. But I think it's the right thing for services like CloudTrail. You should have fixes like this to actually prevent people from doing bad things. So that was an example of monitoring. What about fixing things? Now, arguably, we've already started fixing things. You saw examples of when we're fixing CloudTrail issues. So this is kind of a blending into more stringent fixes. When you want to fix things, you have a wide spectrum of options available. One of the fixes is just knowing that you're doing something wrong, right? A lot of people make mistakes. Well-intentioned people make mistakes because they're just not aware. So creating awareness is a form of fix, I believe. You can have indirect enforcements like tickets, offline conversations, email, or you could actually take direct enforcement actions like we saw with CloudTrail, where you just go and fix it, right? No questions. Now, when you look at services that map to this sort of concept, right, you start at one spectrum, like Trusted Advisor. You don't really have to do anything to get started. It's automatically doing things for you. And if you are someone who looks at the console, you'll see that you're creating awareness, right? This is easy to get started. You're creating awareness of a problem. Now, we saw an example of a config managed rule, which you don't really have to write code for, but you can configure it. So it's a little bit more flexible than the Trusted Advisor rules, but it is also creating awareness. Now, you could create custom config rules where you write the code yourself. And this is sort of more flexible, but you could also write code to fix things. And that gives you some sort of customization where it's a little bit harder to get started than Trusted Advisor because you have to write code. And you saw a CloudWatch events example where you can actually write code to actually take events. And this is, you're moving closer to sort of the building blocks on the right side of your screen. And then you have Trusted Advisor, which is sort of the simplest way to get started. Now, I mentioned CloudTrail data events for S3. Now, this is version 2.0 of CloudTrail, where you're processing high-volume activities such as S3 object-level activity, gets and puts on S3 objects. And these are available very, very quickly in CloudWatch events for you to take an action on, right? And we'll see an example of this. Now, in this example, I have CloudTrail S3 events. And I'm going to enable it, and I'll show you how it's enabled. And then I'm going to create a Lambda function that will apply a specific permission to to the object. And we'll see how quick this is. And this has not been edited, so you'll see how sort of real time this is going to be. Now, when you enable S3 data events need to be enabled for a trail. It's not turned on by default. And I'm going to go to my US East 2 trail. And this is a new section of event selectors. So as I told you, there are filters that you can now set, but we're not interested in that. For this demo, we're going to go and take a bucket and say, this is a bucket I care about. This is an S3 bucket. I want all actions taken on this S3 bucket to be logged by CloudTrail. You've enabled that. Now, I'm going to Lambda, and I'm going to create a function, a blank function, that will apply a specific permission on any object that is put into that bucket, right? Right, and obviously you have to name the function properly, and all of that stuff. Right, and you can pick your favorite language. I think I'll pick Python in this case. And I have some code written up here that I'm going to copy paste. And you can see this is very, very poorly written code. Like I wrote it. So I have print functions all over the place because it's very amateurish. So anybody can do it. I'm just trying to get the event. I'm going to figure out what bucket name and object name was put, and then I'm going to apply, get the object ACL, and then I'm going to put the right set of permissions on an object, right? Relatively simple stuff, just like the first example you saw. I'm going to set up the role and all of that, and then now I have the Lambda function. I've enabled CloudTrail. Now I'm going to plug the two together using CloudWatch events, right? So if you go to CloudWatch events, I'm going to create a new rule that says when an AWS API call is made on S3, and I have this new thing called object level operations, and basically you want this rule to be triggered when someone puts a new object in that bucket, or when someone changes permissions. So put object and put object ACL. And I don't want it for all. I just want it for that specific bucket I just turned CloudTrail on. So that's the random bucket. And then I'm going to connect that to the Lambda function we just wrote. So now we have all these pieces working together. So minor detail, the function I wrote, as I said, was very amateurish. So I have to pass in like a subset of the event. But I'm sure you guys can do a better job than me on that. Name the function, have a suitable description, and then basically what is happening now is I have CloudTrail logging turned on. Now when you turn CloudTrail logging on, that event is always available in CloudWatch events. I'm going to trigger that CloudWatch event. I'm going to trigger a Lambda function in that CloudWatch events that applies the right set of permissions. All this is now set up, so if I go to S3, search for that bucket that I just enabled logging on, I have an existing example there, but I'm going to upload a new object. Something like billing, which is kind of sensitive. And before I start uploading, obviously I want to set the right permissions. I'm going to make it public, right? It's the right thing to do, billing data. And then you upload it, it's pretty fast. And then if you look at the permissions, properties, and look at the permissions on the object, you'll see that there's no public access, right? That doesn't seem right, does it? So you can add more permissions, and I'm going to do the same thing again. I'm going to give everyone the ability to open it, not just view permissions, but also edit it, right? Again, you hit save. The background, CloudTrail's logging this, and then sending the event to CloudWatch events. Lambda function is triggering, and I go to billing again, and I see that permission has disappeared, right? Simple stuff. Of course, if I didn't know this function existed, it would drive me nuts, right? Like, why is this happening? But you see, if you have sensitive information in certain S3 buckets, you have ability to actually automate applying the right set of permissions so people don't do, if people did the wrong thing, like have the wrong permissions on the objects, you can actually fix them. Now, we saw examples of control, we saw examples of monitoring, we saw examples of fixing. Now, I'm a product manager, so you probably you think this is some ideal state that we're kind of envisioning. But I'm going to call Armando here and tell us how he's actually put this in practice at some of our top customers. Armando?
Hi. Thank you, and good morning, everyone. Just a quick show of hands who has heard about the Cloud Adoption Framework. Quite a few of you, right. So just briefly for those that haven't, the Cloud Adoption Framework was published roughly 2 years ago. And in there, we capture some of the best practices that we observed and developed and some good patterns for adopting and operating while working in the cloud, and specifically in AWS. The perspective is broken into 7 areas. One of them being the security perspective, which is the one that we will talk briefly about today. When you look at it, there are 4 angles that are covered. The preventative, detective, responsive, and also the directive side of things. If you were to look at what Prashant has been talking so far from a perspective of control, monitor, and fix, there is really a direct mapping to what is in there, right? When you talk about preventative, it's about preventing bad things from happening. When we're talking about monitoring, it's about having that detective capability to be able to investigate when things deviate from our expectations. And responsive is exactly about getting it back to known good, getting it back to where it should be. There's a 4th one in there, though, that we really haven't talked about yet. And that one, you can see it as being 2 main types of areas covered. One of them which could be pretty much policy-oriented. Thou shall not do X, which could be something related to your industry or coming from external, like PCI or a regulation. But also, there should be a strong strategic component to it, in which you define what are your principles for operating in the cloud. And in this case, I have just a sample set of rules of the road that will regiment in a way, or that we will align by as I walk you through a demo. And I think those 5 things nowadays, they are pretty much common sense, right? One of them is think pipelines, not discrete controls. Maybe a better word in there is workflows rather than pipelines. But what we are saying is when you talk about control, monitor, and fix, these things shouldn't operate in isolation, but there should be a workflow that, or almost like a cycle that takes you from that prevention area. You detect if it is operating as it should. When it isn't, you automate also the fix, and you get back again to the beginning. We provide lots of data and telemetry in AWS. Prashant just went through CloudTrail, Config. There's all the RDS services with its log sources, Redshift, and all other services have a bunch of information that they provide. That's great, but we need to do something with it. Thirdly, and given that we are in a DevOps session, but DevOps and beyond DevOps, we should aim to automate as much as we can. And to that, we get to the 4th, which means the standard operating procedure should be code. If we have a specific situation that requires a run book of 10 steps to be executed, we should be aiming to get those 10 steps to be a single API call that executes on behalf of a human, rather than asking Armando to type and look at the document on the side to make sure we are following that. And lastly, all services are security services. And what I mean by that is, obviously, there are some services that are pretty much focused on the security side of the house, so to speak, things like web application firewalls or Shield released this week or security groups. But that shouldn't stop us from leveraging the wider ecosystem of services that are available out there in AWS to help us with doing security in a better way. I'm going to walk you through a demo. And we are in the gambling capital of the world, right? So in that spirit, I'm going to do it live. Famous last words, right? So what I have to share with you is essentially a 3-layer web architecture, right? It's almost the Alice and Bob of the infrastructure world. And we will walk through a single use case. Our use case is to do with controlling and dealing with logons to the operating system in an instance. Nowadays, it is considered the best practice to operate in such a way that the need to log on to an operating system should be minimized or completely eliminated. But there are always exceptional circumstances that may need to, to a need to do that, be it troubleshooting or something else. So in our case, and I need to go back to the slides, please. Thank you. So in our case, what we have in place is essentially what I have described in there. 3-layer web architecture. By default, our controls are around a set of security agents that are logged on in the instance to do with logging, for example. Could be also AV, etc. We have a process that if someone requires to log on to an instance, they can follow. So an approved way in which we can identify that the right person has the right level of access and should be provided with that access. From a monitoring perspective, we are looking at things from 3 angles. From inside the instance, that's syslog. From the network side, we are looking at VPC flow logs. And from the platform perspective, we are looking at CloudTrail. On the fix bucket, we are good. So right now, we are not doing much. So let me switch. Here we go. So, yep, still in my copy and paste. So right now, what I need is to get access to an instance to perform whatever action. So what I need to do, as I described, is first and foremost, go through that process that will give me my authorization to log on to that instance. And it is just a simple Python script in this case. Don't worry too much about what's in there. It's just for the purposes of demo. Essentially, what it is doing is creating a canary, in this case, that says, yeah, that guy coming from here is allowed to get that instance, and I have authenticated him using IAM. I get my token back. I say, all right, I'm going to type my SSH. I'll use my key to log on to it. I'll put the IP address back in there. I press enter. It says, yes, you are on. Once I'm here, I can start doing all the things that I need to do. Go back, list the directories again, make a mistake. Yeah, everything's looking good. So far, so good. Not much exciting. I SSH into an instance, right? And then I got out. But in the background, there were a couple more things happening. As I logged on into that instance, there was a custom event generated that was sent to CloudWatch events. Essentially, it was saying that, hey, this guy has just gotten access to the instance. He's coming from here. Is he OK to continue? And the other side is validating that canary that I talked about, seeing if I am there, if I am authorized. And it's coming back and saying, yeah, he is good to go. So things continue as they should. Obviously, where we are right now, it means that you need to trust me that what I'm saying is on the right is actually happening. But let's change the conditions slightly. So I was here. I logged out of the instance. And hypothetically, let's say that while I was doing this process, someone with less honest intentions was able to get hold of the credentials that I just used. Or it could be something as simple as I logged out and I realized that I actually forgot to complete one action that I still need to do. And in my rush to get it done with, I just go back and I do SSH again. I get back to the instance and I am in. I start once again doing some more directory listing. I list what processes are up there and running. Hopefully while gaining some time for something else to happen, which will come. But essentially what I am describing right now is that I'm performing an action. For a second, I was feeling a bit shaky, but we are good, we are good. So something else happened this time, right? I logged onto the instance. I did not have the authorization, didn't go through that process that I showed in the beginning in terms of getting a token that allows me to get in. What's happening in the background is a bit more complex now, and I think more interesting. The key thing that I like you to keep in mind is that obviously I am just performing the actions of the end user or the bad guy. Everything that is happening in the back is just all orchestration using a number of AWS services, Lambda, CloudWatch events, log sources, etc. So this time, someone logs back on, we get the same thing. Is the logon okay? And the answer is going to be, no, it's not okay. You didn't request a token, so I don't recognize that. What got triggered in the back is that, okay, so we don't recognize that, but at the same time is logging on as a normal user. So it could be the case that someone by mistake did something that they shouldn't, but it's not that serious. Still, we want to be very watchful about what was going to happen next. So the actions that take place in the back is, let's kick off or go into a state of what I call enhanced monitoring. Enhanced monitoring does two things. First, it will trigger one Lambda that will be focusing in just looking at the operating system log. So anything that is coming from syslog will start be streamed to be, well, it's already being streamed, will be streamed to the Lambda, and the Lambda has a set of heuristics that it's looking for behavior that should determine an escalation in our response. That's the arrow you see in there, subscribe to syslog. Second, besides what's happening inside the instance, I'm also very curious now about any traffic that will be started by that specific instance that I'm suspicious of right now. So I go to the instance itself or through our API, I enable flow logs to start seeing any traffic going to and coming out of that instance at the flow logs perspective. So source, destination, IP, source, destination, and ports. I enable flow logs just for that instance interface. Those data start being sent to CloudWatch logs. And the second Lambda subscribes to that stream. So right now I have two Lambdas, which are the ones on the right. Two Lambdas that are the ones on the right that have a set of heuristics that they are looking for activity inside the instance that could dictate an escalation of my response. And second, also looking at network activity that could be suspicious and should also dictate escalation in response. Network activity that could be strange could be something like the front end or this instance now starts to try to communicate directly to the database. That would be out of the ordinary, and I really want to respond to that. Or that instance starts talking to the database, and it's actually doing so to start an SSH connection. Even more suspicious because my database is RDS. On the OS front, an escalation could be I stop being a regular user on the operating system, and I get to root. Let's go back there. So as you see here, by the way, while I was walking you through, it started also notifying me of all the other actions that were happening in there. Yeah, I started flow logs. I'm var log secure, not the full syslog, just so that we are a bit more targeted. But for the person that is in this instance, after doing some more directory listing, they discover that actually they can become root. Now, for the principle that we defined for the solution that you are working through right now, becoming root is quite a serious event. Hitting my keyboard hard so you see that I'm no longer getting any response from the instance on the other side. So at the back, all those Lambdas that were signing up to these events that were happening, they have detected that there was an escalation on what was happening. The email just got through and saying that I'm taking a set of actions. This thing is now too serious, so I really, based on the logic that we defined, I think it is worth of intervention. Let me switch back to the behind-the-scenes view. So let's zoom a bit on that operating system side of things. We have a message that came in and that say, hey, this is indicative of someone getting root access. That, to me, and in the way that I define things, means that now I have a very high signal, low noise, that something is really wrong and that I want to intervene. I want to move to the fix phase. The fix phase in this case includes a number of things. It's not just fixing, but also responding to the event. First, I want to isolate that instance. I want to isolate it because it could be still important to maintain it for forensic investigation, for example, and for other security incident response purposes. So I deploy a security group that stops all communication to and from it. Let me just back for a second. Another thing that I do is I want to preserve the instance. So what I do is actually also enable termination protection so that no one accidentally or deliberately will just kill it and we lose all access to the memory which could contain valuable information. I deregister the instance from my load balancer and from the auto-scaling group, meaning this instance that I know it's anomalous no longer receives any production traffic. Third, I also want to preserve data for offline analysis. So I'm snapshotting the volumes so I can load to my forensics toolkit and start looking at the file system and see exactly what has led to this. In summary, a number of controls were deployed in there, some of them to do with the security group to isolate things, the preservation of data for investigation, the driver registration from the load balancer, and so on. On the monitoring side, the data sources remain pretty much the same as before, no changes there. On the fixed side, I think, selfishly, that it is quite interesting. Because on the fixed side, what happens is the instance is part of an auto-scaling group. So as I took the actions to isolate and remove it from the ELB, auto-scaling will take back off, launch a new one from known good. So it looked at, it says, hey, actually the fleet is one node short of what it should be, so I will launch a new one from new. The end outcome is that we are back where we started, right? It's back in the first slide, meaning we are back to known good. Now, as Prashant was saying, obviously a demo is a demo is a demo. But use cases, specifically this one that I've shown you and others very similar ones, it's the kind of thing that we've been working in professional service with clients for the past 18, 12 months. More and more creating workflows and automation to both enforce controls and guardrails, ensure that they're operating as they should, and when they don't, as much as possible, try to automate the recovery process. It may sound sometimes a bit complex, or that's too much work involved in doing it, but it's simpler than, I like to say, simpler than it is, I have a short plan in there, which is, essentially the message is, get started, and iterate often, and that will drive you to great outcomes. The second one is if you are still saying, when I say get started, where to start, I'd suggest starting with 5 use cases that I have on screen. Typically, those 5 use cases we tend to implement in the first sprint, so anywhere from a week to 2 weeks to get those defined, what they should look like in organizations that we are working with, what the appropriate response should be, disabling audit trails, switching them back on automatically, and so on. So I think that is a good starting point. I'll take over to Prashant. Thank you. So
excellent demo. So you can actually see this is not something that's hypothetical. Right? This is something that professional services have implemented in some customers. So we're super excited that Armando shared that with us. And also, he's making this code available in GitHub for you to download and use. Right? So the first kit of your take-home toolkit is that the code you just saw, everything you saw, is open sourced and available for you to download and start using. Second, we're starting a series of blog posts in the AWS DevOps blog, the first of which was launched a couple of days ago. So this basically summarizes the things we discussed and has examples of how we've actually implemented these fixes at customer sites. This will be part of a larger series, but we need feedback from you guys to make sure that it's meeting your requirements. And of course, some of the code that you saw here and custom config rules, we have a GitHub repository that has code that you can then use to implement some of these fixes and monitor things. So these 2 take-home toolkits, I know you have had several sessions over the past few days, so it kind of blurs at the end of it. But if you go back home and you have some quiet time, just take a look at this code. It's simple stuff, but very, very powerful. So you'll be able to implement it, like Armando said, in a couple of weeks. We've seen customers actually implement it, so you can too. It's pretty much all we had. Please complete your evaluations, and if you have any questions for Armando, excellent demo, or myself, we're happy to take it. Thank you.